going to solve this first equation by taking the log of both sides. So I'm going to rewrite this as the log of 9 to the r is equal to the log of 93. And this allows me to use the power rule and move this exponent down in front. So I can rewrite this as r times the log of 9 is equal to the log of 93. And now to solve for what r is, I'm just going to divide both sides by the log of 9. And I have r is equal to log 93 divided by log of 9, which that in itself is an acceptable answer, or we can evaluate this in the calculator and get an approximation, which is about 2.063 is the approximate answer to the nearest 10,000th. On this one, we're going to employ the same strategy, but notice here we were not multiplying the exponential by anything. Here we are, so the first step we have to do is divide both sides by 4, because we need the exponential function. We need this piece by itself before we want to start using logarithms. So then I get 16 to the 2x equals 42 over 4. And now I can take the log of both sides. And so now I can use my power property again, which allows me to move this exponent down in front here using the power property. So I get 2x times log 16 equals log of 42 over 4. Put that in parentheses just to ensure that we know we're taking the log of that entire quantity. And now I can divide both sides by the log of 16. And so I get 2x equals log of 42 over 4 divided by log of 16. And again, I want to get x by itself, so I'm going to divide both sides by 2. So divide that by 2. Dividing this by 2 is the same as multiplying by 1/2. Okay, so I can put that 2 there. That's the same as multiplying by 1/2, and so I get x equals the log of 42 over 4 divided by 2 log 16, and again, which is perfectly acceptable, or we can evaluate it in the calculator. And when we do that, we get 0.424. This next expression follows the same procedures, but first we have to isolate the exponential itself. Okay, so first we need to get this piece all by itself before we start taking logarithms of both sides. So first thing I'm going to do is add 6 to both sides. So I get 4 times e to the negative 7x minus 2.5. equals 95. And now I'm going to divide by 4. And so I get e to the negative 7x minus 2.5 equals 95 fourths. Okay, and now since my base is e, when I take the log, I'm going to take the natural log of both sides. So I'm going to take the natural log of the left side and the natural log of the right side. And that allows me again to use my power rule, which allows me to move this exponent down in front. And in doing that, the natural log of e is just equal to 1. That equals to 1. Okay, so on this side we have negative 7x plus 2.5 equals the natural log of 95 over 4. And again, we're going to solve for x, so I'm going to subtract 2.5. So I'll come up here, so I get negative 7x equals the natural log of 95 fourths minus 2.5. Now I can divide both sides by negative 7. So x equals the natural log of 95 over 4 minus 2.5, all divided by negative 7. Okay. So again, that's the exact answer. That's an acceptable answer, or we can approximate this in the calculator. So minus 2.5 divided by, so we get about negative 0.954. Sorry, this is 0.095 would be the approximation to 3 decimal places.